Why is sequential data preprocessing hard for RNS? Imagine trying to read a story where the order of the words keeps changing. It would be confusing, right? That's similar to what happens when preparing data for recurrent neural networks. These networks are built to understand sequences, like sentences or time series. But getting the data ready so the RNN can learn well is not simple. First, keeping the order of data intact is very important. If the sequence gets mixed up or scrambled, the model can't learn the pattern properly. For example, in language tasks, the order of words makes a big difference. If you change the order, the meaning changes too. So, making sure the data stays in the right order during preprocessing is a big challenge. Next, missing data points can cause problems. Sometimes, parts of the sequence are incomplete or have gaps. To fix this, techniques like filling in missing values or smoothing are used. But if these methods are not applied carefully, they can introduce bias or hide important details. For example, filling in gaps with average values might make the data less accurate. Normalization and scaling are also key. Since RNNs process data step by step, features need to be on similar scales. If one feature is much larger than others, it can dominate the learning process. Normalizing helps keep all features balanced, but doing this correctly for sequences can be tricky. Noise in data is another issue. Real-world data often has random fluctuations or errors. Smoothing techniques like moving averages can reduce noise, but overdoing it might hide real signals or patterns. Finding the right balance is important to keep the data useful. Seasonality and trends are common in time series data. For example, sales might go up during holidays or follow certain patterns. Preprocessing steps like differencing or removing trends help highlight the underlying signals. Without these steps, the RNN might focus on seasonal patterns instead of the main trend. Training RNNs also brings its own set of challenges. They often suffer from vanishing or exploding gradients. This means that during learning, the network's adjustments can become too small or too large, making it hard to learn long-term dependencies. This is especially true for long sequences. Training these networks can be very demanding on computers. Longer sequences requiring more memory and processing power. This makes preprocessing even more important, as it can help reduce sequence length or complexity to make training more efficient. In applications like language models or time series predictions, proper preprocessing is essential. Using advanced RNN variants like long short-term memory units or gated recurrent units can help with some of these issues. Regularization and tuning hyperparameters also improve the model's ability to learn from sequential data. Overall, preparing sequential data for recurrent neural networks involves many careful steps. It's about maintaining order, handling missing data, normalizing features, reducing noise, and managing long sequences. When done right, it helps the network learn better and perform more accurately.